Hi guys, in this video we're going to have a look at the equation of a circle, and later on we're also going to look at what happens when you've got a tangent or a straight line going through that circle as well. So let's get some of the basics out of the way first. This is the equation of a circle. X squared plus y squared equals r squared, where r is the radius of the circle. Okay? So if I have the equation of a circle as x squared plus y squared equals 16, one of the more basic questions I could ask you is, what are the coordinates of the centre of the circle? Now, when you have x squared plus y squared, like that, the centre of the circle is always the coordinate 0, 0, or the origin, every single time. X squared plus y squared, the centre is going to be at 0, 0. And of course, the radius of the circle, well, we know that this is the equation of the circle. So in this case, we know that 16 is equal to r squared. So r squared equals 16. So to work out what r is, all I do is the square root of 16, which we know is 4. So the radius of the circle is 4. Slightly trickier one here. If a circle has the equation of this, where x plus 2 is in brackets squared, plus in brackets y minus 5 squared equals 25, same questions. What are the coordinates of the centre of this circle? So to do this, you have to think, what value of x makes that bracket 0? Well, the only answer it could be is x must be minus 2, because minus 2 plus 2 makes that bracket 0. It gets it back to the original, if you like. Okay, so the x coordinate must be minus 2, because that's what x needs to be to make that bracket 0. Same thing here with the y coordinate. What does y need to be to make this equal to 0? Well, if y is 5, 5 minus 5 gets me 0. So my y coordinate would be 5. So that's how you get the centre of this particular circle. Just think about, how do I get these brackets to be 0? Find the x coordinate, find the y coordinate. The radius is very simple. Again, we've got 25 here, so I know that r squared equals 25, in which case r must equal the square root of 25, which is 5. So the radius of this particular circle is 5. So that's if they give you the equations. What they might do is give you the drawings, and again, ask you to work out what the equation is. Well, the first thing I'm going to do is work out the centre. Well, this one's easy. The centre is at 0, 0. Okay, at 0, 0 there, in which case I know that I'm going to have x squared plus y squared. Straight away, just like over here, x squared plus y squared, the centre is at 0, 0, always the case. Now, in this one here, the radius from the centre of the circle to the circumference, okay, is 2. So I know the radius is 2, but don't forget it's the radius squared. So it'll be 2 squared. Then all I've got to do is just work that out to be x squared plus y squared equals 4. And there you go, there's the equation of that circle. Slightly trickier. This one here, x coordinate there, this is the centre, x coordinate is 2, y coordinate is minus 1. So put down those coordinates. In which case, I'm not going to have x squared, I'm not going to have y squared, I'm going to have something like this. So that's the starting point I'm going to do. I'm going to have x squared, and I'm going to plus in brackets y, leave a space for your numbers, we don't know what they are yet, squared, and that's going to equal the radius squared. So this is the starting point. Now, just like over here, I know that x is 2. From this diagram, I know that on the x-axis here, x is 2. So if I know that that is 2, what number needs to go here to again make this bracket 0? Well, if x is 2, that must be minus 2. If I know that y is minus 1, so y is minus 1, what number needs to go here to make this bracket 0 again? Well, if y is minus 1, I need to plus 1 to get it to 0. Okay? So that's how you work out the first bit. The next bit, the radius, well, that's just exactly the same as before. If that's the centre, 1, 2, 3, 4, it goes across 4, so the radius is 4. Don't forget, though, it's the radius squared. Just tidy it up. You'll have x minus 2 in brackets squared plus y y plus 1 squared, and obviously 4 squared will equal to 16. So the equation of this circle here is that. Okay, but always write down your coordinates first, because it then helps you to fill in this bit here. So that's the basics. Let's move on to something a bit trickier. Now, if you introduce a straight line, there are 3 possibilities. There's this one here, where you've got the circle and your straight line completely misses the circle, in which case there's no solutions. You might have this one here, where you've got your circle and you've got a straight line which touches the circle at one place. In other words, this is the tangent, because it just touches at one place, in which case there'll be one solution, which of course will be that point there, where it just touches the circle. And finally, you'll have this one here, where you've got your circle and you've got a straight line going through it, and there'll be 2 solutions, that one there and that one there, obviously where they're the same. So that's just what we're doing, and they're the 3 possibilities. And what you might have is something like this, where it gives you the equation of a circle and it gives you the equation of a straight line, and it'll ask you to work out these solutions. So again, no solutions, 1 solution, 2 solutions. Most of the time they'll ask you for 2 solutions, because obviously it's a bit more interesting and a bit more to do, but just be aware that you could also have these 2 possibilities. This one here, though, does have 2 solutions. And all you've got to do is solve this. Well, essentially it's a simultaneous equation. You've got to solve this by substitution. So you might notice here that I've got 2x minus 2, and that equals y. So what I'm going to do is I'm going to substitute this in for y. Because it equals y, I can just substitute it straight in. So that's what I'm going to do. So I have my x squared, that's the same, plus, now, I'll put brackets around the y especially, because I'm going to substitute this directly into those brackets. So 2x minus 2, and of course don't forget that that y was squared. So I put the squared on there, and that equals 25. Once you've got some brackets, you need to expand them. So remember, squared means I times it by itself. So I'm doing 2x minus 2 times 2x minus 2. So I'm expanding double brackets. So I'm going to draw my grid. And again, if you can't remember how to expand double brackets, check out the video on how to do that. 2x times 2x is 4x squared. 2x times minus 2 minus 4x. Minus 2 times 2x minus 4x. And minus 2 times minus 2, minus times a minus, is a positive. Don't forget to simplify that to be minus 8x. Okay, so that's expanding the brackets, which is what this will give us. So now I'm going to put all that back in. So I still have my x squared, plus, and then I'm going to have my 4x squared, my minus 8x, and my plus 4. And of course that still equals 25. Bit of tidying up, x squared plus 4x squared gives me 5x squared, minus 8x, plus 4 equals 25. Now you might be thinking this is very much starting to look like a quadratic, and you're bang on the money. And that's what we need to do. We need to solve the quadratic. Now before you can solve a quadratic, hopefully you can remember it needs to equal 0. At the minute it equals 25. So I'm going to get rid of that 25 by just taking away 25 to both sides, which leaves me with 5x squared minus 8x minus 21 equals 0. So here's my quadratic that I need to solve. If this was a calculator paper, I would say stick it straight in the formula and get your solutions that way. However, if it's a non-calculator, you'll have to factorize it, which is exactly what I'm going to do here. So again, if you can't remember how to factorize a quadratic, check out my video on how factorizing into double brackets, because this is the method that I'm now going to do. Because I've got a coefficient in front of the x squared, I need to do this trick. 5 times minus 21 gives me minus 105. Okay, so I'm going to draw my grid. Straight away I'll put my 5x squared in the top corner there, and my minus 21 there. Same step as I always do. Now I need to find the two numbers that multiply to get 105 but add to get minus 8. So obviously you can start with 1 times 105 and so on and so on, but the solution that I'm after would be 15 times 7. Okay, 15 times 7 obviously gives me 105, and I can use those by adding or subtracting to get 8x. So it might take a little while to get there, but just check them. So you start with your 1s, check 2, check 3, check 4, check 5, so on and so forth. And then obviously when you get all the combinations, you should have spotted that's the one you want. In which case, let's put it in 15x, 7x. Now if I simplify these two at the minute and add them together, I get 22x. I want minus 8x, in which case I need to make that minus 15. So minus 15x plus 7x gives me minus 8x. Once I've got this and I'm happy, I can then factorise the top row. So what can come out? Well, 5x can come out. And then what times 5x gets me 5x squared? That's an x. What times 5x gives me minus 15x? Well, that's minus 3. And x times what gets me 7x? Well, that's going to be 7. And double check it. 7 times minus 3 is minus 21. Brilliant. I've got it here. So what is the answer when I factorise it? Well, in one bracket, it'll be my 5x plus 7. In the other bracket, it'll be x minus 3. And again, that equals 0. So I need to work out what x needs to be to make this bracket 0. I need to work out what x needs to be to make this bracket 0. So I'm going to, obviously this one's easy. What does x need to be? That needs to be 3. So that's my first solution. X equals 3, because 3 minus 3 is 0. This one's a bit trickier. So just come over here, and we know it needs to equal 0. So set it equal to 0, and then just rearrange it. I'm going to minus 7 from both sides. So 5x equals minus 7. Then divide by 5, both sides. So x equals minus 7 over 5. And that's your solution for that one there. X equals minus 7 over 5. Don't forget though, once you've worked out the x coordinate, you need to work out the y coordinate. So I'm going to substitute this into this line here. So I've got x is 3, so 2 times 3 is 6, take away 2 is 4. So y equals 4. So that one's nice and easy. This one here is a little bit trickier. So I need to substitute it into this. So y equals 2 times my 7 over 5, which is my x value, and then take away 2. So y equals 2 times minus 7 over 5. Think of it as a fraction, so 2 over 1. 2 times minus 7 minus 14. And then 1 times 5 is obviously 5. And again, I need to take away 2. Now I'm taking away 2. Remember, I need to make my denominators the same. So at the minute, it's 2 over 1. What number is in the 5 and the 1 times table? Obviously, it's 5. So minus 14 over 5 can stay the same. I need to times both top and bottom here by 5. So my denominator is now the same. And now I can just take them away. So minus 14 minus 10 gives me minus 24. And of course, my denominators stay the same. So it's minus 24 over 5. By all means, you can change it back to a mixed if you wish. It's entirely up to you. How many times does 5 go into 24? Well, it goes in 4 times, but don't forget it was minus 24. So it goes in minus 4 times. What's left over? 4/5. So you don't have, I'd leave it like that personally, but you can convert it. And they're your solutions. When x is 3, y is 4. So there's the coordinates of where it would touch. And this one here, x is minus 7 over 5, and y is minus 4 and 4/5. Okay, and that's your other coordinate of where it meets. Obviously, that's not the diagram for this, but that's what you're after. Okay, so one last thing to have a look at. And that's how you find the equation of the tangent here. But before I do that, we're going to work out the equation of the circle. So just like we did in the very first one here, I've got my centre is at 0, 0. So I have x squared plus y squared. And what's the radius? 1, 2, 3, 4, 5. The radius is 5. Don't forget to square it. It's x squared plus y squared equals 25. So there's the equation of the circle before we do anything. The next thing I need to do is work out the equation of this tangent. So remember, a tangent is just a straight line that touches at a single point, and that single point is here. Now in the exam, sometimes they give it to you, the coordinate I mean, or sometimes they might just give you one part, might just tell you what x is, or they might just tell you what y is, in which case substitute it into the equation of a circle and work out what the other value is. So if they give you x, work out what y, if they give you y, put it into there and work out what y is. Okay, so how do we do this? Well, the first thing we need to do is work out the gradient of the radius, okay? Because from the centre to the tangent, this is a 90 degree, in which case these two lines here are perpendicular. So if you're unsure about how you work out the equation of a perpendicular line, check out my video on, I think it's straight lines, I think it's part 3, which is perpendicular lines. So check out that video, and then this will make a lot more sense, but obviously I'll go through it. So the first thing you need to do is work out this gradient. So hopefully you can remember from your straight line work that the gradient is the change in y divided by the change in x. So what I'm going to do here is I'm going to draw a little right angle triangle like so. So what is the change in y from this coordinate to this coordinate? Well, it's 1, 2, 3. I've gone down 3, so remember it's minus 3. Across here from 0 to 4, what's the change in x? It's 4. So the gradient of the radius will be minus 3 over 4. Now, if you didn't spot this was a negative 3, just look at the gradient. It's decreasing, so your gradient will need to be negative. So if you're a bit unsure about your minuses and this, that, and the other, have a look. If your gradient is decreasing, it must be a negative. So once I know the gradient of the radius, I now want to work out the gradient of the tangent. So the gradient of the tangent. Okay, now this is where you have your m1 times your m2, so the gradient of your radius times the gradient of your tangent, that needs to equal minus 1. Now if you watch the video, I tell you a little trick to do. Obviously you can substitute these in and rearrange it, but it's a bit of a pain. But if you remember the little trick, all you do is you flip the fraction, and if it's a negative, it becomes a positive. If this was positive, this would become a negative. So in other words, you just change the sign. Because that's negative, this needs to be positive, and I've already flipped it. So that's the little trick you can do, or of course you can just substitute it into there and rearrange it. But the trick's a bit quicker. So the gradient of the tangent, this here, is now 4 over 3. And again, look, because it's increasing, that's positive. I know it's right. Okay, the equation of a straight line, again, hopefully you remember this, is y equals mx plus c, where m is a gradient, which we just worked out. So I'm going to put that straight in. Y equals 4 over 3x plus c. The last bit to work out is the y-intercept. To do that, I need to have a coordinate, so I can substitute my x value in and my y value. So it just so happens I know what this is. The x coordinate is 4, and the y coordinate is minus 3. So that coordinate there on the line, x is 4, y is minus 3. So substitute those values into here. So that's my x, that's my y. So y is minus 3, so minus 3 equals my gradient, 4 over 3, times x, which is 4, and then plus c, which is my y-intercept. So let's do a bit of rearranging here. So minus 3 equals, well, 4 over 3 times 4. Think of it as a fraction. 4 times 4 is 16. And then 3 times 1 is 3. So 16 over 3. And of course, plus my y-intercept. All I need to do now is just minus this 16 over 3 from this side. So minus 16 over 3 from both sides. That leaves me with minus 3 minus 16 over 3 equals my y-intercept. Just as before, I need to subtract these, so I'm going to think of minus 3 as a fraction, so minus 3 over 1. But again, before you add or subtract fractions, your denominator needs to be the same. So I'm going to times this by 3 to be minus 9 over 3 minus 16 over 3. Because my denominators are now the same, I can take away the numerators. So minus 9 minus 16 minus 25 over 3, which is my y-intercept. Once you've done that, don't forget to go back and substitute it into your equation as your final answer. So y equals 4 over 3x plus your y-intercept, which we know is minus 25 over 3. And there you go, there's the equation of the tangent there. Okay. So what you could do here, I suppose, you might want it in a different format. Because that's divided by 3 and that's divided by 3, you could times everything by 3 to have 3y equals 4x minus 25. Don't have to do that, but it's just something that you could do to make it a little bit tidier. So key things here to remember. Gradient is the change in y divided by the change in x, not the other way round. If it's a negative gradient, check it that your gradient is also negative. Decreasing, negative. Increasing, positive. That's where lots of people go wrong. Next thing is when you put these coordinates in, make sure you put the x as this one here and the y as this one here. Lots of people put them the other way around and they therefore get this stage wrong. And of course, be careful when you're adding or subtracting your fractions. Other than that, hopefully that makes sense. And yeah, cheers for watching. Thanks, guys.